Hello everyone, my name is Tutor Mamugo and you are welcome to Oxidation Academy. Now if you are new to my channel, kindly hit the subscription button below, also like, share and of course avail yourself to the lessons so as not to be left behind. Welcome back. So in today's lesson, we're going to be learning about oxidation numbers. Okay, so we're going to be learning how to calculate oxidation numbers and the rules that pertains to solving for oxidation numbers. But first things first, before we can even start solving, we first have to understand what oxidation numbers are. Now, what are oxidation numbers? Oxidation numbers are those numbers assigned to ions to determine loss or gain of electrons. So oxidation numbers are those numbers assigned to ions to show the loss or gain of electrons. So, for example, whenever you see an element carrying a charge at the top, whether it's a +1 charge or a +2 charge, that lets us know that that element has lost electrons. So a positive charge shows loss of electrons, while a negative charge shows gain of electrons, which leads us to electropositivity and electronegativity. So I'm going to quickly recap on that. So what is electropositivity? Electropositivity is the ability of an element to lose or donate electrons. So electropositivity is the ability of an electron to donate electrons. Okay, while electronegativity is the ability of an atom to gain electrons. So that is why a positive charge shows loss of electrons because it was donated, while a negative charge shows gain of electrons because why it's accepted. So please take note of that. So that is the definition for oxidation number. So what are these rules that we need to know when solving or calculating for oxidation numbers? So we're going to be going through them one by one. So the first rule is this: elements in their free and uncombined state have an oxidation number of 0. Okay, so take note. Elements in their free, uncombined elemental state have an oxidation number of 0. So for example, aluminium, chlorine. Okay, so whenever they exist uncombined with another element, not in a compound, okay, they have an oxidation number of 0. So that is the first rule. So for rule number 2, metallic elements often have more than one oxidation number. So your aluminium, your zinc, your iron, etc. often have more than one oxidation number. Okay, so how do we determine the oxidation number of our metallic ions? There are two ways. One, in combination with another element. So if you know the element it is combining with, you can easily determine the oxidation number of that element. For example, in the case of aluminium chloride, so AlCl. Okay, so we know that chlorine has an oxidation number of -1. Why? Because chlorine is a halogen, and your halogens belong to group 7 on the periodic table. Now, because chlorine belongs to group 7, it has an oxidation number of -1. So if chlorine has an oxidation number of -1, and we have 3 chlorine ions, for that compound to equal 0, aluminium has to have a charge of +3. So I don't know if it makes sense. Okay, so we will explain this later on, but your oxidation numbers must equal the charge. If you have 3 chlorine ions present, for that compound to be balanced, as for that charge to equal, for those oxidation numbers to equal the charge, aluminium has to have a charge of +3. But we already know that because why? We know that aluminium has an oxidation number of +3. But this is when you do not know the oxidation number of the metal ion. So that is one method. Another method is through the Roman numerals attached to the elements. So for example, you can come across a compound iron 3 chloride. So that 3 is usually in a bracket in Roman numerals. Whenever you see that, just know that that 3 is letting you know the oxidation number of the ion or the metal attached to it. Okay, so metals or transition metals carry their oxidation number in their name. I believe I explained this in my previous video. If you are yet to watch that, please check that out on my channel. Okay, it is titled writing formulas for ionic compounds. Okay, so that is that. So they carry their valencies, or they carry their oxidation numbers in their name. So these are the two ways of determining the oxidation number of your metal ions. So that is rule number 2. Now for rule number 3, take note, oxygen always often have an oxidation number of -2. Okay, so oxygen often has an oxidation number of -2, but there are exceptions. What are the exceptions? Number 1, in peroxides. So when you see hydrogen peroxide, oxygen does not have an oxidation number of -2. Rather, oxygen has an oxidation number of -1. So in hydrogen peroxide, or in peroxide generally, oxygen has an oxidation number of -1. Also, oxygen has an oxidation number of 0 when it is in its free state. Remember, for rule 1, we see that elements in their free state have an oxidation number of 0. So whenever oxygen, which is O2, is in its free state, it has an oxidation number of 0. So please take note of that. Also, oxygen has an oxidation number of +2 whenever it is bonded to fluorine. So these are the exceptions why oxygen will not have an oxidation number of -2, but typically oxygen has an oxidation number of -2. So that is for rule number 3. Now for rule number 4, we have hydrogen. Now hydrogen typically has an oxidation number of +1. Okay, but the exception to that is when hydrogen is combined with a metal. So in the case of your hydrides, so for example, sodium hydride, whenever hydrogen is combined with a metal, it has an oxidation number of -1. So, but typically, hydrogen has an oxidation number of +1. So please take note of that rule. Then for our rule number 5, we know that the total oxidation numbers of a compound must equal the charge of that compound. So when you calculate the total oxidation numbers of your compound, it must equal the charge of that compound. That is to say that if the compound has a charge of 0, or if it has no charge, rather, the oxidation numbers when calculated must also have a charge of 0. Okay, if the compound does not have any charge at all, the oxidation numbers when calculated must equal 0. Also, this also applies if the compound has a charge of -1. The oxidation numbers when calculated must have a charge of -1. So this is also a great way in knowing if your calculation is correct. Okay, so when you calculate, or when you add up the oxidation numbers of the elements in that compound, if it does not equal the charge, rather, if it does not equal the total charge of that compound, then you know you are not correct. Okay, so this is a method of checkmating yourself. So as for rule number 5, the total oxidation number must equal the total charge of that compound. Okay, so that is for rule number 5. For rule number 6, fluorine always has an oxidation number of -1. Okay, so in case you do not know, fluorine is the most electronegative element in the periodic table. Remember, I told you that electronegative means accepting electrons. Okay, so fluorine is the most electronegative element in the periodic table, and because of that, it will always accept electrons. It will not donate. So it always has an oxidation number of -1. Mind you, fluorine is also a halogen and it belongs to group 7 in the periodic table. And like I said, elements in group 7 have an oxidation number of -1. Okay, so but for fluorine, because it is so electronegative, there is no exception to this rule. Fluorine has an oxidation number of -1. Okay, so for your group 1 elements, they have an oxidation number of 1. Your group 2, an oxidation number of 2. Your halogens have an oxidation number of -1, except when bonded to oxygen or fluorine. So these are some of the rules that you can use in learning to solve your oxidation numbers. Okay, so if you understand these rules, solving for oxidation numbers becomes very easy. So in our next class, we're going to be moving forward with calculating oxidation numbers. If you are yet to watch my previous videos on writing chemical formulas, please check that out in my YouTube channel. Also, if you are yet to like this video, give us a thumbs up, and of course share, subscribe, and avail yourself to the lesson so as not to be left behind. With that, I remain your tutor, Ogeneti Mamogo. Have a wonderful day.